Yes, who all are joined? Kindly type your name. Who is there? Ryan. Who joined? Can you type the name? Who is there? Those who attended, they can type their names. So today we are proving total kinematics equation. All the three derivations we are doing today. Okay, so we are doing each derivation one by the graphical method. Already that methods we did in the class 9 also. But today we are deriving all the three kinematics equations which we discussed in the last week. Okay, so total we have three kinematics equation. So what are the three kinematics equation? V is equal to u plus at. Then we have here v square minus u square is equal to twice of as, and s is equal to ut plus half at square. So these are the three kinematics equations we have, and that three equations we have to derive one by one. Okay, so Jaireen and who all are there? Abdul, Ishan, are you there? Okay. So graphs we are discussing afterwards. Okay. So first we are doing the normal graph for velocity and time. Okay. So if you take a velocity and time graph, suppose if we have a graph like this is a x-axis. On x-axis there is a time, and in y-axis we have a velocity. Okay, so all the basic terms we did in the last class, and that velocity is there. So in a given time period, that object is moved from A to B. Suppose this is A and this point is a B. Okay. But if suppose if you are taking this as a origin O, so O to A is nothing but your initial velocity, that is u. Okay, and from where the point B it stops, so from that if you drop a perpendicular thing, then this is nothing but what your v. Okay, and suppose if I join this over here, so only suppose this you are taking point C, then this point B to C is nothing but how much here, v minus u, because total is nothing but what, your entire B2, suppose if I am taking this as a D, B2 BD is nothing but V, then BC is nothing but how much here, V minus U. So this is what the graph we have, and we have to derive from the same graph, from the velocity and time graph, we have to derive the three equations. So already these three equations we did it in the class 9. Okay, so how to simplify this, how to get the equations one by one, that we have to discuss now. Okay, so here first we have to prove the v is equal to u plus at. So it is very simple, no? So acceleration, okay, so O to A means object is what, initially travels with the initial velocity u, and the final velocity will become v. And if we take a difference B to C, that is if I want atmos distance, that distance if I want B to C, then B to C is nothing but what, total final velocity minus initial velocity. So here we have to derive V is equal to U plus AT. So do you have any idea how to derive this? What do you mean by acceleration? This is so very simple. Acceleration is nothing but what? Acceleration is nothing but change in velocity divided by what? Time, no? So just rearrange the terms. At is equal to v minus u. Therefore, we can keep v as it is. U transpose to this side. So u plus at. That's it. This is the derivation for first equation. Okay, it's the same graph we have to use here. Okay, and the same, by with the help of this we are proving the second derivation, v square minus u square is equal to twice of as. That also we can discuss. I hope first one you got it. Okay, it's only take the definition for acceleration. Acceleration is nothing but change in velocity divided by time. Okay, so once you get this, then we have to go for the second v square minus u square is equal to twice ut, twice of as, that we have to prove. So for that, how can we find out? Does anyone know by graphical method? How can you go? How can we find out? So if you check to find out this v square minus u square twice of as, so in that case you can consider this as a trapezium. Which one trapezium? Here A O D B. So can you see here? Consider a trapezium. Consider a trapezium AODB. Can you able to see AODB is a trapezium? So if I take area of a trapezium, what is the area of the trapezium? Area of the trapezium is nothing but what? The sum of the two sides divided by 2 into height. So sum of parallel sides divided by 2 into height. This is nothing but a formula for trapezium. Okay, so sum of the two sides AO is parallel to BD. So I will write AO plus BD. These are the two parallel lines, AO and BD, and that I will divide by 2, and height you can take, no, as a OD. You can take this height as a OD. So area under the graph, okay, area under the graph is nothing but what? Total area. Okay, but AO and BD, AO is nothing but U, BD is nothing but your V divided by 2, and height OD is nothing but what? Time, no, T. Can you getting this? So once I will get this, then this is what my area. Area is nothing but what? Total distance or total area under the graph, that is nothing but S here. Okay, then T is nothing but what? See, observe here, just now I did here. T is nothing but what? Instead of here, see, you can check this step. So I have here AT is equal to V minus U, then T is nothing but V minus U by A. So that this point, suppose if this is my equation number 1, then this is my 2. So put 2 in equation number 1. Okay, so S is equal to, you can write here, U plus V divided by A. U plus V divided by 2 into T is nothing but what? V minus U upon A, correct? So here if you observe U plus V and V minus U, that is nothing but what? A plus B, A minus B, and that is nothing but what? V square minus U square. So here only I will solve. S is equal to V square minus U square upon this 2 into A is a 2A. So here I can write V square minus U square. 2A you can transpose to this side, twice of AS. This is what the second kinematics equation with the help of graph. So first one is very easy. We took acceleration. Acceleration A is equal to V minus U by T. Just adjust it and then you will get V is equal to U plus AT. And to prove that V square minus U square is equal to twice AS, you have to consider same graph, but you have to take here total area of the trapezium. You have to consider the trapezium, and area of the trapezium is nothing but what? Sum of the two parallel sides divided by 2 into height. This is what the formula. And once you get the formula, then arrange that, put all the terms, arrange the terms, you will get the answer. So here sum of the parallel side is AO and BD. AO plus BD. Okay, divided by 2. And here height is nothing but what? Always we are taking perpendicular side. We can't take this AB. Okay, you can take a BD also. But here this is a perpendicular. Okay, OD. So I took OD as a height here. So OD is nothing but what? This is the time axis. So U plus V by 2 into T. Very important step. T is nothing but V minus U upon A. So substitute that T over here. So S is equal to, you are getting U plus V by 2 and V minus U by A. So here A plus B, A minus B is nothing but A square minus B square divided by twice A. Rearrange the terms, so you will get a second kinematics equation. Okay, think it properly, you will get the proper derivations. Okay, so already these derivations we did in class 9. So I hope you all are getting these derivations. Ishan, are you there? Angel, Jareen, Ryan is there, that I know. Okay, I hope everyone is getting this. If you have a time, copy immediately or just okay, Abdul, no issues. Okay, so those who are present, they can take a screenshot or you can write down. Ryan, are you getting? Jareen, Angel? Okay, Ishan. Okay. Now we are going for the next part, that is S is equal to UT plus half AT square. I hope you have a derivation, you copied this or maybe you take a screenshot. Okay. So we will go for the next one, that is the third one. So third is nothing but what? S is equal to AT plus UT plus half AT square. Again we have to consider the same graph, only the area we are taking is different. In last case we took entire trapezium, but here total area is nothing but what? Split this triangle and this rectangle. Area of triangle ABC plus area of a rectangle AODC. So you can write down this area. So area of a triangle, here it makes 90 degree, no? So area of a triangle half into base into height plus area of a rectangle is nothing but length into breadth. So half I will keep it as it is breadth into height. So here base is nothing but what? AC, and height is nothing but BC, plus length is nothing but for this rectangle length is OD. You can take AC also, okay, and breadth is nothing but CD. Okay, so here half. So what is AC here? A to C is nothing but what? As a OD, no? So AC and OD are parallel and equal. OD represents the time. Then AC also represents a time only here. So I will keep the value of AC is a T and BC. BC is this part. So BC I already told you, if the BD is a total velocity, final velocity, and AO is the initial velocity, then only I want BC. So final minus initial, that is V minus U. So I will write here V minus U plus OD is nothing but here length, that is time, and CD is nothing but breadth, and that CD and AO are same because in rectangle opposite sides are equal and parallel. So AO is nothing but U, then CD is also U. So I will write here U. Okay, and total area is again what? Area is nothing but what? S here. So I am writing here S. Okay. So once you will get this, then we have to substitute the values over here. So we have here S is equal to half V minus U. See, already I did here A is equal to V minus U by T, and here I have V minus U. So what I will do, I will transpose this T to this side. So V minus U is equal to 80. Okay, V minus U is equal to 80. So here time into 80 plus UT. So if you check here, half T into T square A. 80 square plus UT is nothing but what? Your third kinematics equation. So here I derived all the three kinematics equation. Only thing is that we are changing the areas. Okay. If you are taking total trapezium, then you will get the V square minus U square is equal to twice of AS. If you are taking area and rectangle, area of a triangle and area of a rectangle, and you are combining, then you are getting equation S is equal to UT plus half AT square. And first one is very okay derivation, easy and simple. There only we have to take acceleration, and in the last class we did acceleration is nothing but change in velocity by time. So change in velocity is nothing but what? V minus U divided by T. So just arrange this, you will get the answer. V is equal to U plus AT. So these derivations are very important. Mostly they will ask during the exam. Okay. So I will give a time. You can copy. Finished. So now we have a next graph wala part. I hope everyone is copied, took a screenshot. Ryan, Ishan, Angel, Abdul, Jerry, you took the screenshots. Getting this? Ryan, are you there? Can you getting this? Okay, chalo. We will go for the time displacement time graph, velocity time graph that we can do. That also has a weightage in the exam point of view. Okay, so first give the heading, the displacement time graph. Displacement time graph. So displacement time graph means suppose if we are considering here graphs, okay, here we have a time and here on the y-axis we have a displacement. Okay, so when a body is at rest, I will mention the condition when body is at rest condition. When body is at rest condition, so time is changing but that body is what, always in rest condition. It is not at all moving, there is a no motion you are observing, you are increasing the time, time is changing but that object is there only, that means it is at a rest condition, object does not show any movement, that is nothing but object is in a motion. So this is what straight line, that is nothing but the object is in a rest condition. Suppose the body is moving with constant velocity. Suppose if I have here time and this is what we have a displacement axis, that is y, and I will mention here condition body is body moving with constant velocity. Okay, then body if moving with a constant velocity, that means there is a zero acceleration. If zero acceleration is there, that means that body possesses, that body is moving with a constant velocity. That means what, in first hour it covers 10 kilometers of distance, in second hour also it covers 10 kilometers of distance, in third hour also it covers 10 hours of 10 kilometer hours of distance. So in every successive time period it covers the same distance, that is nothing but what, your constant velocity. So here constant velocity, that means we will get a linear graph. This is known as what, linear graph. Okay, so body moving with constant acceleration. Okay, suppose means this is B, then C I will write here body moving with constant acceleration. Constant acceleration means what, there is a change in velocity, that body is what, moving with a change in velocity, and that change in velocity is what, constant. Okay, means suppose in first hour it covers 50 kilometers of distance, and in second hour it covers 40 kilometers of distance, and in third hour it covers 30 kilometers of distance, and next again it covers 20 kilometers of distance. Means what, there is a change in velocity but that there is what, difference of 10 kilometer. So if that kind of body is there, means which is showing constant acceleration is there, then the graph will become, this is time and there is a displacement, and that displacement is nothing but what, the constant displacement is there. So constant acceleration is there, so this we will get a graph like this. Okay, then suppose body is with a retarded, moving with constant retardation. The body is moving with constant retardation. This is time, this is displacement, and that retardation is nothing but what? Retardation means there is a decrease. Okay, there is a decrease in acceleration. So this you will get a graph. Okay, so these are the four graphs we have. The displacement and time graphs we have in our syllabus. So they will ask to identify, or simply they will ask to draw. Okay, so these graphs are there. These graphs are very simple. Okay, time displacement में time is changing, body is in the body is not showing any movement, that means body is in a rest condition. If body is moving with a constant velocity, then we will get a linear graph. If body possessing constant acceleration, then you will get this kind of graph. It is continuously increasing, and body is moving with a constant retardation, means there is a change in acceleration but that is decreasing. So that is what you will get a graph. It is increasing and now started decreasing. Okay, decreasing means that shows the constant graph over here. So these are the four graphs we have in our syllabus. Can you getting this? Copy this. Okay, copied up to here. Okay, everyone copied this. Give a heading displacement time graph and copy everything. You can give a heading displacement time graph and draw these graphs, or you can take a screenshot and you can copy it afterwards. Okay, and then we can go for the next VT graphs, that is velocity time graph. Give a next heading velocity time graph. Give the heading velocity time graph. Okay, so here on the x-axis we have a time. Okay, and y-axis we have a velocity. Okay, and if you check this graph, in case of VT graph, a body moves with constant velocity. A body moves with constant velocity. That's it. This is the first graph. Okay, time changes, body is also moving, but the change is what remains same. Okay, velocity will remain same everywhere. Okay, and this is nothing but what? This graph, a body moves with constant acceleration, this is here along the y-axis we have a velocity. Okay, so copy this. Okay, and if we take this body, if we take this graph here, we will get velocity, and the body is moving with increasing acceleration. Increase in acceleration. Okay, so these are the graphs, and one more graph is there for this. body is decreasing acceleration, body is a body is moving with decrease in acceleration. So if we have a time and if we have a velocity on the y-axis, so with the decreasing acceleration we will get a graph like this. Means time increases, velocity is what? Decreasing. So that is nothing but what? Decreasing graph. So copy these, two more are there, that also I will explain. Okay, copied. If they are asking retardation graph, okay, suppose if they are asking body is moving with constant retardation, okay, body, last one, body moving with constant retardation, then actually it contains some velocity and now that velocity is decreasing, so we will get a graph like this. Okay, copy this. Okay, everyone copied. So can I go for the next graphs, that is acceleration and time graph. Acceleration and time graph. Give the next heading, acceleration and time graph. So acceleration time graphs are also there. So here we have only three graphs under the acceleration and time. So here always remember, on the x-axis we are taking t, okay, and on y-axis we are taking acceleration. Only three graphs we have here, okay. So first we are taking a body moving with constant velocity, or not constant velocity, constant acceleration. if body is moving with a constant acceleration, then you will get a straight line graph, and an object is moving with increasing acceleration, then you will get a linear graph. So linear means this means in first hour 1 kilometer, in second hour next 1 kilometer, like that. So a body moving with constant with constant constant increasing acceleration, constant increasing acceleration. Okay, and last part, that is body is moving with a decreasing acceleration. A body moving with constant retardation or constant decreasing acceleration. Decreasing acceleration or retardation, both are same. Okay, and that retardation we are getting that downward graph. Okay, so these three graphs we have. Okay, copy these graphs. I hope everyone took a screenshot. Now, motion under gravity. Okay, so motion under gravity, that means an object is freely falling. Okay, so give the heading. I hope everyone is copied this. So motion of a freely falling objects. Motion of a freely falling objects. Okay, so now here we have to discuss about the free fall. Okay, so what is a free fall, that we have to discuss. Okay, so free fall, so always remember, if object is going vertically upward, then that acceleration is replaced by minus g, and object is going downward, that acceleration is replaced by small g. Okay, freely falling object is nothing but what? देखो हाँ, freely falling object means whenever I drop this pen, this will not fall down. I didn't apply any force. Okay, there is no external force acting on this body, so I am just dropping, then it is going towards the ground. Means what? Earth is having a gravitational force and it try to attract the bodies. Even we are also walking, that is an example of gravitational force. So any object, if we are throwing opposite to the direction of gravity, in that case its acceleration is nothing but what? Negative. And that acceleration we are taking it as a acceleration due to gravity, that is nothing but g. Okay, so normal straight line acceleration is a. Okay, but object, if the object is what? Freely falling here, object is freely falling here, then instead of that normal acceleration, we are replacing the value of acceleration by g. G is nothing but acceleration due to gravity only. Okay, and its unit is nothing but meter per second square, and practically we are taking the value of g is 9.8 meter per second square, but sometimes we are solving with the value of g, that g value is approximately 10 meter per second square. Okay, so this is also what? One kind of acceleration, but this acceleration we are calling it as a acceleration due to gravity. Can you getting? And here in this point we have these equations. V is equal to u plus at. Here we have v square minus u square is equal to twice of as, and we have here s is equal to ut plus half 80 square. So these are the kinematics equations just we learned, we derived this. So whenever the object is freely falling, we don't want to derive anything, but acceleration we are replacing. Okay, so how these equations will come? Dekho here. So this V will remain V, U will remain V. Suppose the body is moving in an upward direction, then this A will become what? Minus G into T if the body is going upward. Okay, so here also V square minus U square twice of minus G into S. S is nothing but here height, because here the object is moving vertically upward. That means we are taking height. And here S is also height here. H is equal to UT plus half minus GT square. Can you getting this? And this you can write it as V is equal to U minus GT and V square minus U square minus twice GH, and H is equal to UT minus half GT square. I simplify. That's it. And if the body is going in the downward direction, then we are writing V is equal to U plus GT, V square minus U square is equal to twice of GH, and here we will get H is equal to UT plus half GT square. So these are the equations we are getting. Okay, if the body is a free fall. Okay, you can copy. I'll come in 2 minutes. You can copy, write it down properly, value of G and all, everything you have to write. Yes, everyone copied, no? So I think I covered almost all the points. Well, check once, and if anything is pending, that I will teach. Okay, by tomorrow, but today we'll do some questions. Okay, so we can do some questions. Write down the question. A train starts. A train starts from a rest. A train starts from a rest and accelerates uniformly and accelerates uniformly and accelerates uniformly accelerates uniformly at a rate of at a rate of 2 meter per second square 2 meter per second square for 10 seconds for 10 seconds. Calculate the final velocity of the train. Calculate the final velocity of the train. Okay, I'll repeat the question. A train starts from a rest and accelerates uniformly at a rate of at the rate of 2 meter per second square for 10 seconds. Calculate the final velocity. Okay, so here read the question. Train starts from a rest, so that means train initial velocity is equal to 0, no? Correct? They are asking us to find out a final velocity, that is v. Okay, and they are saying here the speed accelerates at the speed. So acceleration is given 2 meter per second square and time is given here 10 seconds. So they are asking us to find out the final velocity v. So we have a first kinematics equation, v is equal to u plus at. It's very important what is given and what we have to calculate. That should be clear in your mind, then only you can apply the formula. Okay, and reading of the question is very important. They are saying train starts from the rest condition. That means its initial velocity is 0. So we I want to calculate here 0, a is 2, t is 10. So we have a 20 meter per second. Okay, this is the final velocity. Copy this. I hope you are getting this. We are started questions from simple problems. Okay, and then slowly we can go for difficult questions. Okay, everyone copied this. Write down the next question. Write down next question. A car is moving with velocity. A car is moving with velocity of 10 meter per second of 10 meter per second, full stop. It accelerates at a rate of it accelerates at a rate of 2 meter per second square. It accelerates at a rate of 2 meter. Hello. हो बघतो तुला 10 मिनिटात सांगते मी जाते खाली आणि सांगते क्लास हां हां नाही बघते थांब मी आता जाऊन मी सकाळी विसरून गेले पप्पाला मी शोधायला सांगितलेलं मी सांगते हां हां. So here they are saying a car is moving with a velocity of 10 meter per second. It accelerates at a rate of 2 meter per second square. It accelerates at a rate of 2 meter per second square for 5 seconds. For 5 seconds, calculate the distance traveled. Calculate the distance traveled. Calculate the distance traveled by the car during this time. Calculate the distance traveled by the car during this time. Okay. So here read the question. Okay. A car is moving with velocity. Okay. So here initial velocity is given. Okay. So initial velocity is given 10 meter per second. This is what initial velocity they gave. Okay. And it accelerates at a rate of, means acceleration is given 2 meter per second square. You can just check a unit. Then once you check the unit, you know the units, then you can identify what is given. And it accelerates 2 meter per second square for the 5 seconds. Okay, time is given 5 seconds. Okay, and they are asking us how much distance will it cover. Means S we have to calculate. So if I want to find out S is equal to what? Ut plus half AT square. You can use this formula. And another formula I have, V square minus U square is equal to twice AS. Here also you will get, but the problem is that here we have to calculate V. Okay, by the formula we have no A is equal to V minus U by T. So that formula we have to use. So that increases the calculation. So instead of that we can calculate here. So U is here 10, time is 5 plus half, A is 2 and T is nothing but 5 square. 2 get cancel, here 50, 5 square is 25. So answer is here 75 meter. Is nothing but what? Total distance cover. Distance only no they are asking, or what? Speed? Yeah, distance only they are asking. That is 75 meter is the answer. Getting this? Very simple questions are there. You have to think on this and write down the answer. Check what are the given quantities and always remember what is our aim, means which value we have to calculate. Okay, everyone did? Write down the next question. A bus is moving with velocity. A bus is moving with velocity. A bus is moving with velocity 20 meter per second. A bus is moving with velocity of 20 meter per second. It shows down with uniform retardation. It shows with uniform, it slows down, not shows, it slows down with uniform retardation of 4 meter per second square. 4 meter per second square. How long will it take? How long will it take for the bus? How long will it take for the bus to come to stop? To come to stop. Very important question. Mark it as IMP. I will repeat this question. A bus is moving with a velocity of 20 meter per second. So velocity, initial velocity of that bus is given 20 meter per second. Okay. So u is here 20 meter per second, and they are saying here 20 meter per second, and it slows down with uniform retardation. Retardation is acceleration, but acceleration is what continuously decreasing, that means retardation, and that acceleration is nothing but what, 4 meter per second square, and as this is decreasing you can take with negative sign. Okay, and they are asking here how long will it take for the bus to come to stop. Okay, so how long, that means time is t here, we have to calculate, and at the end the bus will become what, at the stop, means it is stopping, that means it will become in a rest condition. So v is equal to what, 0. So we can use the formula v is equal to u plus at. So v is nothing but here 0, u is nothing but 20, a is nothing but minus 4 into t. So u 20 you can transpose, minus 20, and this is minus 4t. So minus and minus get cancelled, and t is nothing but how much? 4 5s are 20, 5 seconds. So it will become rest in 5 seconds. So time is nothing but here 5 seconds. Can you getting this? Okay. So I will stop here. Again tomorrow we will continue the numericals from the same chapter. So I will finish this and then we can go for the practice for chapter 1 and chapter 2 on a regular basis. This time is fixed, I will not change. Okay. Maybe 3 or 3:30, because before that I have a 10th and 12th batch, so sometimes if I change then it takes a time. Okay, so thank you for joining, and I'm ending this session. I hope everyone is copied the questions and answers.